Okay, so I guess we can slowly start. Next up is Fernando Teixeira.
Teixeira. Yes, it's difficult.
Okay, great. About Fernando, senior software engineer in test with over 7 years of experience developing the test automation solutions. He's fascinated by technical details in software development and DevOps practices. Frequently does pair programming, knowledge sharing session with his colleagues. So I guess you would like to share the knowledge with your colleagues. Experienced in establishing test automation processes from scratch on multiple projects. I must admit that I was kind of amazed with the spectrum of of your work when I was preparing the bio. Okay, yeah, and coaching about the QA automation practices and technologies. Fernando, everyone, thank you.
Thanks a lot for the introduction. Hello everyone and good afternoon. So, my name is Fernando and I'm really glad to be here today to talk about microservices testing. That's one of my favorite topics in the testing field. And in order to better explain the details of how to create a test strategy to test microservices, we are going to talk about challenges using real examples. Then, we're going to talk about solutions to those problems that will be part of our test strategy. But before we jump into that, let me quickly introduce myself, just add a few more information into that. So, as I said, my name is Fernando, and I currently work as a lead QA engineer in Verivox. It's a German comparison portal company where people can compare prices for different kinds of tariffs, like energy, insurance, and so on. I currently live in Heidelberg, in Germany, but I'm originally from Brazil. Maybe you know it's by the name. And I really like working with anything related to backend and microservices in general. So I have been focused on that for quite some years already. And in my free time, I'm mostly cycling or playing chess. I still have a lot to improve in chess. Unfortunately, I make so many blunders, but I like to play it. So now, let's start talking about why microservices are so popular and why so many companies and projects are using it. So first, microservices are everywhere. It's something much beyond just a trending topic. It's one of the most used and common architecture patterns in the industry. Also, microservices is not something new. It was already created a really long time ago. However, the technologies to develop and deploy it are always in a constant evolution. Every day we have new tools, frameworks, technologies coming to the market to make it even more efficient. And all those improvements make it possible to apply microservices to very different use cases and situations, fitting into projects from startups to big techs. We have companies like Amazon, Netflix, and other big techs, where the microservice universe has scaled to something almost chaotic, like the image which we have right here. Each small dot here is a microservice in their ecosystem. They are interconnected, and together they are able to provide the desired functionality to the end user. And the reason for our success is not in vain. Scalability, faster deployment time, fault isolation, programming language agnostic, and it brings more independence to development teams. Those are just a few of the great advantages that microservices can bring to your project. However, we also have some drawbacks when adopting it, and some complexity comes with it. First, it requires a good collaboration between the different teams involved in the project. We have many dependencies between the microservices. Second, there is some operational complexity in the process of deploying and release different versions of the services into different environments. And also, we have many different testing challenges that we're going to see more details during this presentation and learn how we can overcome them. So we know that microservice testing is more complex, but we need to understand why it's more complex. So we understand the problems first, then we can propose the right solutions for that. So let's deeply dive into that. And in order to better explain those challenges, we're going to take an example to make it more visual. So let's imagine that we are building an e-commerce. And first, we have the possibility to build this e-commerce as a monolith, where inside this monolith, we're going to have different layers and services that are important for an e-commerce to work, including orders, products, shipment, and payments. This monolith will also be connected to a single database that will store and return all the data that we need. And also, this monolith will be connected to a website front end that will be the interface between the monolith and our end user. Here, I could also list many other services that generally are important for an e-commerce to work, like, for example, orders, or like subscriptions, users, many other things. But here, I don't want to make things too hard, and those 4 services here should be already enough to exemplify the ideas that we want to talk about. But then, we wanted to take advantage of the different benefits that microservices can bring to our project. So we decided to split this monolith into microservices. And as you can see here from the diagram, we still have the same 4 important services: products, orders, payments, and shipment. But now, instead of having a single database to store and return all the data that we need, we're going to have dedicated database to each one of the services that we have right here. And also, we're going to need to make direct API calls to the specific service which we need. Here in this diagram, I'm illustrating only the checkout process. That happens because I wanted to simplify this diagram. Otherwise, it would be just so many errors going around right here, connecting the different components of this architecture. But just to say that, for example, let's imagine that the website front end just needs some information from products. Of course, we would have an error here connecting both, and the website would just be able to get this direct information from product service, right? So that's basically here the idea, how that looks like, this checkout process. And it doesn't look so complex, right? It looks fine so far. But we're going to see in the next slides some challenge that comes with this new setup that we have right here with the microservices. First challenge, much more integration points. So, going back to our diagram, when we are talking about like a checkout process, which involves like all those different services right here, we have all those arrows that represent integration points between components of this architecture, right? And all those integration points, they could also, of course, for some reason fail. A failure could happen between order service and product service. For example, order service is sending the wrong data or making the wrong request to product service. A failure could happen inside a specific service. For example, the payment service is down or there is a bug in the logic of making payments. A failure could happen in the communication with the DBs. For example, the data required was not found in the database, or the database was down. So in summary, when we are talking about like a checkout process here, which involves different services like we have right here, we need to consider all those integration points that we have in this flow, and making sure that all those integration points will not fail. It's a huge challenge. And that's why we need to take that into consideration in our test strategy. Second challenge, distributed databases and the test data management process. Going back to our diagram with this microservice architecture, as I said, here with microservices, we have dedicated database to each one of the services right here. And the database will have data specific of the domain that they are part of. So for example, products database will have data related to products, orders database will have data related to orders, and so on. And of course, when we are talking like a process that involves all the different services right here, sometimes it can be necessary to put some data into each one of those databases, or to put them into a specific state to support this whole operation. To make this more concrete, let's have a look on how the checkout process actually works. the checkout process actually works by the user, making a checkout through the website. The website will then call the checkout API, which is part of the order service. Then we have order service calling the product service to get the data from each one of the products that are part of the order. Here, as example, we can have a product that contains ID, a name, and a price. And in order to return some data to the order service, we would need to have already present in the database a set of products to properly return it to the order service. And that's basically an example of data that we would need to have already present in the database to support this operation. Next, we have order service calling the payment service to process the payment provided by the user. Here, as an example, we have a payment with ID, a valid, and method. And we can have many different payment methods, like credit card, debit card, PayPal, etc. And also, all those different payment methods, it's something, a kind of data that we need to have already present in the database to support this operation. Then we have order service calling the shipment service to process the delivery of this order. Then, as an example, we have a delivery that contains an ID, a method, and the estimated delivery time. As a method, we can have many companies providing this service, and as an estimated delivery time, we can have many different days. For example, one company can take 3 days to deliver the order, another company take 5 days, and that's basically also an information that we need to have present in the database to support this operation. And finally, the checkout process is finished by the new order being saved into the orders database. So, in summary, after showing all this flow right here, what can we take from that? For a process which involves all the 4 different services right here, we needed to set at least 3 different databases into a state or with the necessary data to support this kind of operation. Our example here is still very simple. It's just a few databases. But we can imagine for a real scenario, let's say a company that has hundreds of databases with their microservices, how much time and effort it could take in order to properly insert the required data into each one of those databases. And that's a huge challenge. And that's also why we're going to need to take that into consideration in our test strategy. Next challenge, different teams work in parallel. The coordination is difficult. So in our e-commerce project, we can imagine that we have different teams involved in this project, right? Those teams are independent, and they can work in parallel on different versions of each one of the services that we have right here. So we have Team Beta, Alpha, Gamma, and Delta working on the different services that we have right here. And we can imagine that we have a staging environment. And in this staging environment, we have the version 1.0 of each one of those services deployed into that environment. Now, since we are working on a continuous development process right here, we're gonna always have new versions coming on from each one of those services. And then we can imagine that we have Team Beta developed version 1.1 of product service and deploy that into a staging environment. We need now to make sure that everything is still working. All the different end-to-end flows right here are still working after this change is introduced to the environment. Next, we have more changes coming up, more versions from those services. We have then Team Beta developed version 1.2 of product service, and Team Alpha developed version 1.1 of order service, and deploy that also to a stage environment. We need again to make sure that everything is still working. So you got the idea. We have more versions coming on. Team Alpha developed version 1.2 of order service. Team Gamma developed version 1.1 of payment service, and deploy also to the same stage environment. Again, we need to make sure that everything is still working, right? But now comes the challenge. We also have a production environment. And in production environment, we have different versions of each one of those services deployed into that environment. And it could happen that we, like here in that situation, we have products version 1.0, orders version 1.1, payments version 1.1, shipment version 1.0. And this is a combination of versions that we did not validate together in a staging environment. And it could happen that order service version 1.1 just works with product service version 1.1 or more. And here we have the version 1.0. That basically means we have here a breaking change. Our shakeout flow will not work. And that's a huge challenge in terms of testing. Ensuring the retrocompatibility of all those different versions from all those different services, it's something complex to be done. And then we need to take that also into consideration in our test challenge. That's also a huge challenge in terms of testing. Next challenge, asynchronous services. Again, the same diagram. In our project, I mentioned that we have the 4 different services here communicating with each other. However, I didn't mention how this communication actually works. Services can communicate synchronously or asynchronously. A simple example of a synchronous communication could be the relationship and the communication between order service and product service, where, for example, order service needs some information from products in order to continue a certain process. So since it's a kind of thing that we need to wait for a response from the order service, that's basically an example of a synchronous communication between 2 different services. But there are some situations in our project where we don't need to wait for a response from the other project, from the other service. The best example here is the communication between order service and shipment service, where, for example, we could have the situation where after the checkout's made, we can send a few minutes later an email to the customer with all the tracking and delivery information of his order. So since it's something that can be done a few minutes later, that's basically an example of synchronous communication that can happen between those 2 different services. And to make this asynchronous communication to work, we can add one more component here to our diagram. Yes, a message queue. That's the new component in our diagram. That could be Kafka, RabbitMQ, or any other message queue technology that you prefer. And message queues can deliver the orders, the messages in a different order than they arrived, and also the processing can take some time. That basically means if we want to validate if everything worked as expected, it's going to be just much more complex, since we don't get a response immediately, and also not in the same order. That also means if we want to have an end-to-end test to validate if everything worked as expected, we're going to require some extra mechanisms, like, for example, maybe checking if the messages in the queue were processed, or checking in the database if a new shipment was created, and so on. And most of the time, those extra mechanisms, they just can take much more time and effort to be executed, or sometimes they can just be much more complex to be also executed. And that's also a huge challenge in terms of testing. And that's also why we're going to take that into consideration in our test strategy. So, in summary, this is some of the main microservice testing challenges that we need to deal with when working with microservice projects. We have much more integration points. We have distributed database and the test data management process that gets harder. We have different teams working parallel that brings this retrocompatibility test challenge that we talked about, and also the asynchronous services that we just discussed about. So those are just generally some common challenges in terms of microservices, but of course, depending on the project that we're working on, we can have even more or different ones than those. And after showing all those different challenges, the question is how to deal with those challenges, right? And that's what we're going to see. To deal with those challenges, we need to have a test strategy. that takes all those different challenges into consideration and mitigate the risks in a cost-efficient way. Also, it should provide enough confidence to the different teams involved in the project when they are releasing a new version of their services. Also, it should take into consideration the cost to create, run, and maintain it when defining what will be part of this test strategy. So let's finally start setting up our test strategy and discuss what will be included there. First things first, we need to have unit tests. Unit tests are generally underrated by most people. Sometimes they are not properly created, or there are just some very basic unit tests part of the solution. This is a kind of test technically always present in every test strategy. They are really cheap and fast to create and run and maintain them. And also they can cover many different parts of our application. Also, it can help us to validate important pieces of our services logic in isolation, including especially some layers like controller, service, repository, mappers, all those different parts of our services that contain some important logic that can be validated in isolation. And besides the testing benefits, it can also be a powerful design tool for developers to write better testable code using approaches like, for example, test-driven development. And of course, to properly show you how those different layers of tests will properly put it into practice, we're going to continue using the same diagram. And that's how it looks like, how the unit where exactly the unit test would help us to cover. And as I said, it will focus especially on those internal layers of our services, including those like a controller, service, repository, mappers, all those different parts of our services that can be validated in isolation, and then we can properly validate also the logic of those services. Next, we also have integration tests as part of this strategy. So far, we have already provided considerable coverage with the unit test, covering all the different layers of our tests of our services in isolation, those important parts of logic. But we still need to test if all those different layers can properly work together as expected. And also, we need to verify that the services can properly communicate with some external components, like, for example, database and queues. And even though we are going to check this integration with some external components, we are still not going to test the integrations with other services with the integration tests. Because we want to have first a specific test, integration test in that situation that can validate one service in specific without creating dependencies between the release process of different services at this point. The proper test between microservices will be done in a different kind of test that we're going to talk about later. And also, our goal is always to reduce the cost, effort, and time to create, run, and maintain those integration tests. So using some in-memory or lightweighted Dockerized database and queues can also be a very interesting idea in order to make easier to run those tests locally and CI/CD. That will help us to run those tests more frequently and faster, and also, in consequence, detect the issues more easily. And this is what it looks like when putting the integration tests into our diagram here. As we can see, we have already provided considerable coverage of different components here from our architecture using the integration test. And as I said, it will focus especially on this integration with some external components here, since we want to have the integration test to be able to validate one service in a specific without creating dependencies between the release process of different services in that situation. The next kind of test, part of our strategy, are the contract tests. Contract tests it's getting more and more popularity over the last few years. The most popular testing framework at the moment to implement contract tests is PACT framework. Maybe some of you have already heard about it. when it comes to microservices, it's a really interesting test that focuses on the communication between different microservices. So basically, the contracts will contain the request and response expectations between those services, so then we can verify that the dependencies between those services is satisfied. That's a powerful mechanism that also helps us to validate this integration between those services without the need to deploy everything into a single environment. It's a really interesting thing that comes with the contract test, and also we're going to see a little bit of that in more details in the next slides. And of course, it's also a very long topic that could have its own presentation. But today, it's important to highlight that it can help us to deal with the retrocompatibility test challenge mentioned in the beginning of this presentation. That happens because the contracts will have different versions, and we also have different information from the services, like brands, environments, and also have some information of where those services and the versions are properly deployed. And to see a little bit of that in practice, what I have just mentioned, that's how it looks like, the mechanism from Pact Framework to check the retrocompatibility of different services. And here in this table, we have order service and product service. Here, order service is our consumer, and product service is our provider here in this relationship. And to analyze the table, I know that it's a lot of information here, but to analyze this table, let's just quickly go through that. We can start by looking at the last line. At the last line, we have the version 1.0 of order service in production environment, and we validate that against the version 1.0 of product service also in production environment. As we can see from the status column, this verification has passed. That basically means versions 1.0 of both services can properly work together as expected. The contract is satisfied. Then, on the second line, we have the version 1.1 of order service in a staged environment, and we validate that against the version 1.0 of product service in production environment. We can see from the status column, this has failed. So basically, this new version, 1.1 of order service in a staged environment, cannot properly work together with this version 1.0 that is already in production. And then, on the first line, we have the version 1.1 of order service in a staged environment, and we validate that against the version 1.1 of product service in a staged environment. And we can see from the status column, this verification has passed. That basically means both versions 1.1 can properly work together. That also means if we want to deploy both versions 1.1 together to production environment, it will work as expected because the contract between them is properly satisfied. And also, another very important thing to notice. The second line has failed, right? And it's not because version 1.1 had a bug, right? It's just because the communication between those two servers is not just satisfied, right? And that's also a very interesting thing to notice right here. Sometimes it's not about a bug that was introduced to the service, but it's just because there is not properly a compatibility between different versions of the services. And also, contract tests can also help us to deal with another test challenge mentioned during this presentation, the asynchronous test challenge. That happens because the contract tests can help us to validate some synchronous communications, like for example, API REST requests, but also it can help to validate some asynchronous communications, like for example, messages flowing through a queue. And that's what we also have here on this contract on the right, where we have the metadata and the body expected in this message that is flowing through the queue. Here in this diagram, we have order service pushing messages to the queue and shipment service consuming those messages. In that situation, order service is going to define the contract with the data that it is pushing to the queue, and that's also what we have here in this body with like the different products part of the order and also the delivery address. And at the same time, shipment service is going to validate if he is able to consume this exactly same information. That basically means once we can validate that one service is pushing the right data and that the other service is able to consume this exactly same information. Going back to our diagram, this is what the contract test would help us to cover. And as we can see, they will focus especially on this integration between different services, whether their communication is synchronous or asynchronous. And our last kind of test, part of our test strategy, are the integration tests, or are the end-to-end tests, sorry. So we have already provided considerable coverage with all the different levels of tests here, part of our strategy. So we can consider focusing only on the parts still not covered by the other tests, right? And that's also why we're going to try to create as less as possible end-to-end tests, because they are the most expensive kind of test here, part of a strategy, when we compare with the costs from the other tests. And also, the end-to-end test, one of the goals from it is to exercise as much of the fully deployment system as possible. So at the end, it will help us to validate the integration with some components that maybe were not tested by the other tests. So for example, some extra infrastructure components such as firewalls, proxies, API gateways, load balancers. So things that are part of the infrastructure in general that were not part of those other tests. And also, the end-to-end test should help us to verify that the system as a whole meets the business goals. So we want to focus on user scenarios and full functionalities that are important for the end user. And going back to our diagram, this is what the end-to-end could help us to cover. And by looking at the diagram, maybe you could ask yourself, are the end-to-end tests not supposed to cover everything from this diagram? Well, yes and no. It depends. As I said, the end-to-end tests are the most expensive kind of test, part of our strategy. And we want to make it as efficient as possible. So we want to cover and focus especially on parts not still covered by the other tests. And for example, shipment service, this integration with the database, with the queue, and with other service, we have already covered that with other kinds of tests, right? And that's also why we don't need to invest too much time and effort on that. And as I said, the goal for the end-to-end tests are to focus on those maybe extra infrastructure components that are still not tested, such as firewalls, proxies, and so on. Here in this diagram, we don't have those components, but of course, I can say that in a real project, we would have at least a few of them for sure. And also, our goal with the end-to-end tests are to cover the whole business scenario from the user perspective. And also, that's the reason why we have the front end covered with those end-to-end tests, right? So since we are considering this user perspective in that situation, we're going to also take the front end in this coverage right here. So you can, of course, also use other frameworks that can go through the front end in that situation and validate the system as a whole. So, at the end, this is how it looks like when putting everything together into the same diagram. I know that it's very difficult to see with everything together like that, but I just wanted to show it at the end to demonstrate how the different levels of test, part of the strategy here, can already provide a considerable coverage of different low levels of duplication right here. Tests that are just much more cheaper to be created, like integration tests, for example. And when we have those tests properly set up, like the end-to-end test and the other manual checks are like just the cherry on the top of the cake. And that's basically it. But before I finish, just a short conclusion and a few takeaways from this presentation. First, learn how to adapt your test strategy based on the architecture and its challenge. Every architecture has its own details and challenges, and we need to understand them first in order to create a test strategy that fits into it, as we saw in this presentation. Second, each test have their own goals, and they should complement each other. As we also saw, we don't need to invest too much time and effort only in end-to-end tests, only if, we have the other layers of tests properly set up, covering all the different low levels of duplication. When we create tests in a way that they complement each other, we can create something that reduces the cost, effort, and time to create, run, and maintain those tests. Also, before choosing any test type or any tool in specific, it's very important for you to understand your challenge that you are dealing with. That is not like a single silver bullet tool that will solve all your problems. That's not just for microservices, but for many of the things that we are talking about in software development. And also, that's one of the reasons why we have so many test layers right here. Like for many people, maybe contract tests can be seen or be sold as one of the heart, as this test strategy, but that just works if we have the other layers properly complementing it. And last but not least, monitoring and release techniques like canary and blue-green deployment can also help us to detect other application issues, especially in production environment. That's also another very important point that could have been added to your test strategy, and it's also something very interesting to talk about. Since it's a long topic, we don't have time to talk about that today, but of course, it's also something to consider in our test strategy. So that's basically it, and thanks a lot for joining me today. With this QR code, you can get some links for different places where you can contact me, like LinkedIn, GitHub, or per email. Thanks a lot.
Thank you very much, Fernando. Let's have a huge round of applause, yes. Do you guys maybe have any questions to Fernando?
Hi. So nice presentation, but I have one question. So how to deal with those, let's say, testing of different versions of the microservices? I mean, let's say I have some integration tests, and I know that some new tests are written for example, version 1.1, but still I need to run some of them for version 1.0. Or just check something on, like do some kind of health checks on production. So how to deal with the versioning in the tests?
Yeah, that's a real struggle. And as I try to say here, like generally, for this retrocompatibility test challenge, right? The best approach for me at the end were the contract tests, because at the end you just need to make so many other validations, of course, not just like for a single one-to-one relationship in that situation. So that's why the contract test in that situation fits very well to solve this retrocompatibility test challenge, because in a very short time frame you can validate so many different compatibilities and versions in that situation. So that's why I consider that the contract test as the thing to solve this challenge.
Okay, any other questions?
Hello, I have a question regarding performance testing. In this architecture, what do you think is the best place where we can run these performance tests? Does it make sense to test separately these microservices, or rather end-to-end approach? Thanks.
Yeah, that's a good question. So here in that situation, I focus more on the functionality, but of course we have so many other quality attributes, like just for example the performance, that is something that we of course need also have a look. And generally it's a good approach to try to validate specific services individually, especially if, for example, you have a specific functionality that goes through a specific server, for example, right? So in that situation, a functionality depends on one service specific being functional and being performant. So that's generally also a good approach to have a specific performance test to also validate that this specific service is functional. But also, of course, when we talk about functionality, as we saw, that involves so many different services, we also need to make sure that all the services will be performant together. So that's also something that you need to take into consideration, how the functionalities are structured in your application, and then you can think about if it makes sense to validate one individually or one as a whole.
Any other questions from anyone?
Hello, thanks you for presentation. Could you recommend any specific tool for contract testing? I know the packed one, but maybe you know another one.
Yeah, there are a few other ones, but to be honest, I still think that Pact is more robust at the moment to most of the things that you want to do, right? It just supports so many different programming languages, so independently of the language that the microservice is implemented, you're gonna find probably a support from Pact. The other services are mostly, for example, I know that in Java, in the Java world, there is something like Spring Cloud, I forgot the name. But I know that for the Java world, there is a very specific one. But from my experience, like Pact generally fits better into most of the situations. And as I said, it also fits to most of the technologies that you're also working with.
Okay, any other questions? If not, then once again, thank you, Fernando. Once again, have a good round of applause.